It's time to make some adjustments. Welcome back to the channel. I'm your host Ken Johnson. Today we're going to be making some adjustments to my kayak. In a previous video I had talked about the ability of the kayak to not operate like it needs to, and I'll explain some issues as we go along. Stick around. So if you've watched my last kayak fishing video, I was talking about how the kayak needed some sort of trolling motor or something other back here to keep it stable because it just wasn't working. Then I had a neighbor I was talking to, and he had a similar problem. I was like, oh, you use a Skeg. Then I was talking to myself. I said, Self said, huh? I was like, you're an idiot. Self like, yeah, I already knew that. Glad I'm not you. I went, huh? Self went, huh? Anyway, so what we came up with is, why don't I use a Skeg? If it's good enough for me to advise my neighbor, and I'm good with the paddling, I just have a problem with what's called watercocking, which is, or weathercocking, not watercocking, but weathercocking. It's where the weather is pushing around your kayak, and the fact that the kayak is not being true when going straight because it's so light in the water and it's being moved around so much. Why not just put a Skeg? So that's what I'm going to do. I'm actually going to use a retractable Skeg design here. Now, one of the things I do hate about this Pelican kayak, this is the Pelican Catch Classic 100. It's right there, you can see that. But what I do hate about it, there is no system in here where you can access this. Now, other kayaks have an access port here, and I really would like that because I would like to have some type of bolt and nut putting this in place. I think it would be better, but I don't have that, so that's going to be an issue. Another issue we have here is that there is a kind of an angled method here, so it's angled, it's hard to see, but it's a slope going down, so it's nothing flat. So that means I've got to come up with a shim or something other for my base plate so that it's kind of level, and that's going to be difficult to do. I'm going to have to just kind of keep whittling away until I get something kind of level. So this is not going to be precision work here, but you're dealing with a molded plastic boat. So they don't really have anything that way as far as access. Moreover, they don't have any type of like ports or anything drilled in, or where you can drill in here, so there's nothing to go through to access stuff. They really did not consider this as a kayak, an entry kayak that people could modify over time. And I think that was short-sighted. This is the kayak that many kayakers all started out with, and it is probably the best paddle kayak per dollar spent for stability and ease of use at the low end item kayak spectrum. So, you know, there are other companies out there that they provide kayaks are way better than Pelican. I'm not saying that, but I am saying that Pelican, by far, they have the best bang for the buck at this price point. So you can expect to get into a Pelican Catch 100 for around $600. I paid a little less, but every year it goes up. I don't know when you'll be seeing this video. I'm doing this 2024, so you could expect this to be around $600 more or less, no matter where you're at in 2024. So they did put a little divot there, which I find interesting. So I could order a hatch. I'm just not going to do that. That probably be the best thing. If I decide later, I may do it, but I just wish Pelican treated this as something that you could modify over time. I'm going to go ahead and try to invoke my inner Marty. So if you never watched Zawfinger, he is probably the pioneer on YouTube for kayak modifications. If you never checked him out, you need to check him out, because he has modified a kayak any way you can possibly imagine. So I'm going to take some measurements, and then we're going to see what we need to do. First thing you need to do is measure out this little trough here. So just going where it kind of comes down at the bottom. I've got a maximum of 3 inches I'm working with. I need to come out, and so my base coming out here, I've got 4 inches. So 3 inches by 4 inches is what I'm working with in this location. So I'm gonna write that down. All right, my level won't fit. So what I did is, this is a piece off of a Harbor Freight tool, and it's got a little leveling bubble right here. And so I'm gonna put it on here like this, and then that'll help me figure out where level is roughly, and then I'll measure the distance from end down and see where we're at to see how much of a shim I really need. So I'm gonna come out, I'm gonna see where 4 inches is here. Say 4 inches, roughly right about there. And then that's going to put it right about here. Now let me see. That's level. It's actually level there. See where. Roughly about 5 millimeters. No, actually about a centimeter off. All right. So that's interesting. May be able to, if I did like this, it's actually not that bad. Not as bad as I thought it'd be. I may not need a shim. If I do, I'll account for that. So Let me mark that down, that I've got a centimeter. On the edge. One of the other things I'm also looking at is making an anchor trolley system. I tend to anchor from my right side for whatever reason, and although there is this little keeper thing right here on the side that you can use, I rarely ever use it. So I think I'm going to set up a very simple, affordable trolley system. I'll show you how to do a front end and a back end, because I have two different types of anchors I commonly use, and I won't be able to use them interchangeably. One thing that we did not account for is the height of the handle. Height of a handle is roughly 1.5 inches, so we can't come up any more than 1.5 inches high. So whenever you're doing any type of DIY project, you should always look at, you know, what the tool is or what you have on hand. Now this is a piece of a milk crate that I cut off the bottom part, and I've made a milk crate for my kayak that I use for my audio-visual stuff. So if you want to see how I do my audio-visual kayak crate build, just let me know in the comments. I got video footage, I just haven't made it yet. So anyway, I looked at it. We're looking at well under 1/2 inch, right at 1/3 of an inch right there. We're looking at about 2 inches here, and not even 3 inches here, about 2.5 inches. So this is perfect for me to do as my bottom plate, and then I'll have another bottom plate that will go over this, and then with these holes here I can actually use this to drill and fuse my plates together. So that is awesome. Alright, to make this easier to understand, I've took some chalk and outlined. This right here is going to be a base plate. This right here I'm going to cut to make an arm, and this one right here I'm going to cut to make an arm. This center part's going to be you know, cut out, and then this right here is going to be 2 side plates. This will all make sense in a minute when I get everything cut. To cut my plastic, I am going to be using a rotary tool. I went into Harbor Freight. I've been catching flack on a video that I did a while back called about a pump that I consider to be just a bad pump, and I've caught a lot of flack on it. Well, I went to Harbor Freight. I was going to get just some little minor tools from my Dremel, and this right here for the rotary tool and all the attachments. You can see all the attachments there, all that stuff. They wanted less than what it would cost for the attachments. So I got all these additional attachments and a rotary tool for less than $8. Can't beat that. Now I'm going to do some grinding on this. They said to wear protection. I don't know why, but I didn't agree with them, but I went ahead and went down to the gas station, to the men's restroom. I got some protection. I don't know how that's going to help me grind any better or use this Dremel tool any better, but oh well. Oh, pardon me, I need to take my safety glasses off. You should always wear your safety glasses. I don't know why the instructions said wear protection, but whatever. As you can tell, the oscillating tool did a much better job of this. So I just was using wrong tool for the job, which, you know, that's what she said. Anyway, so now what we're going to do is take the rotary tool and just kind of trim off some of this, sand off this to make it kind of all nice and even as best we can, and then we'll fit these up and you'll see how this works. So, but basically this is base plate, side arms will go up here like this, and then we're going to have some side things here as well, so you'll see these, and I'll show you how all this fits in, so it'll make sense in a minute, I hope. But yeah, we'll have all this ready to go. Alright, so all I've done is I've put the parts together. I'm just taking a little bit of Harbor Freight super glue. This is not going to hold it together for permanent. It's just so that it holds it together in the temporary, so that I can get this fitted together. And that's all I need. Now I'm going to show you a little trick. This is baking soda, and I'm just putting baking soda in that hole that I filled. Got right here. Got baking soda in here, and it will cause the super glue to instantly cure, and then that will allow me to add another layer. Now I've got some more I'm filling in right here. I just flipped it over, and I've got the super glue in there. baking soda. All I'm doing is just filling this in. And this will cause it to actually be harder than regular super glue, and it'll make for a strong connection. It won't be watertight, and I wouldn't rely on it for rigidity, but for a temporary hold. And that's all I'm needing is a temporary hold. This will work. And then I'll just add a few more drops. And some more baking soda. It don't take much. I didn't even use a quarter of a teaspoon for both these right here. Okay, we've been doing arts and crafts here. So what I did is I took a ruler and my measuring tape. I measured out 2 inches, measured down 6 inches, measured out 4 inches, and then I measured down here to 18 inches. And what I did is I used whatever I had that was round. In this case it was some electrical tape, and I just kind of rounded off lines until I got something kind of propeller shaped. And so that's the propeller. This right here, I just took this, laid it right about here, kind of measured it out. That's going to be the cover. I've still got to measure out the base here, and then that was going to be the bottom plate, and I've got to do a fork in it. So this is the basic design of everything. Sorry about that, the battery cut off. My next camera will not be a GoPro. But basically this is the rough design. Now there's been talks about whether or not you should turn this knife blade back away from the boat, or whether or not you should turn it the other way. Some designs have it one way, some designs have it the other. I don't really know. This is that bottom plate I was talking about with a fork. So there'll be a bottom plate there, and then this is a rough side design. And then this is how it's going to flip up and down. So kind of give you an idea of what's going on. Alright, so I had to do some weird arithmetic here. So because of the design of this and the width and everything, it came out to being, it was better to use centimeters here. So I used 3.5 centimeters. I went up 4 inches because I'm trying to stay in American as much as I can. And then because the width of a 1/3 of an inch is 0.8 something centimeters, I just made this a centimeter. It was easier. And then again, using the tape, I made my little fork. So this is my template for the bottom plate. So this will go on the bottom. This is where the skeg will fall into place. And then we got the outer cover here. And the outer cover will be on each side. And so it'll all be one color. This will actually fit underneath this. So this will actually be sitting like that. It's hard to see on this table here, but this piece of plastic will go on the bottom of the kayak, and then this will go on top, and that's going to be cut out of something else. And then I'll drill through everything, and then I'll secure it to my kayak, and I'll show you that. Alright, so the material we're going to be using for the outside and base plate is cutting board. Now Walmart had a sale on the 12 by 18 by 1/3 inch cutting board. It had a handle and they were all out. This is a Amazon special, Bino. They're calling it a non-porous cutting board. It's also called a super board. One of the things that people have been saying over and over is that it scratches like crazy. And they're not kidding. I mean, it came to me scratched. I mean, just being in the warehouse a little bit, moving around, it's already been scratched up. But what I'm going to do is cut out this template, and basically I'm going to just do the template, lay it out, draw it out around it. After I cut out template, I'm going to draw and put all my little pieces together and cut out of this board here, and then you'll see when I'm done. Alright, so it's hard to tell, but the magic marker does leave kind of a red line, so you can see the two sides. That's pretty much a straight line there, so I just took it. I'll sand as I need to, but that's pretty much good there. Cut right there. That gives me roughly half that in case I need extra, so I'm trying to maximize space. And if I wish to make another one or whatever, I've got it. So that's the game plan. I think it's always important to talk about your mistakes as much as you do your successes. In fact, I think your mistakes are more important because you learn from them. So I was telling somebody how this worked, and I was demonstrating with these pieces. And one of the things I noticed is that this is set up wrong, because this right here is going to have a bolt coming through it, and then the fin will be coming around like this, or was supposed to, or actually supposed to come around like that. Anyway, either way, it's going to hit that base plate, and a skeg has to be vertical, straight vertical. So that's when I realized I had it all wrong. I've got to have that be like that, to where the actual skeg, when I do it, that little hole right there is coming out like that. Meant that this other piece I've had to elongate it out, so I had to make that a little longer. That's this piece right here, and that piece right here will then be, like I said, longer, and it will come out around here. Then this other piece will be right there, and the shroud part, the little fascia thing that keeps everything going, it will come out here, so that will actually still act as structural support, and it'll keep everything together. So that's the new design. So what is the reason for telling you all these mistakes? What did I learn? Well, I mean, I was trying to show how everything worked as far as putting pieces together. I never was demonstrating how it actually worked. As soon as I demonstrated how it actually worked, I immediately saw the problem. So looking at it from different points of view is a good thing. And it's kind of sad because my job is a mediator, and my job is to make sure that people see different points of view. But when it's yourself, it's very difficult to do that. And so this was a lesson to me about points of view, and just really questioning my thoughts. So there we go there. The other thing that I noticed that I may have a problem with is that this base plate is going to be a little too thick for the screws I have going down to the kayak. I may need to do that where I I get longer screws. But another thing I might have to do is sand down a little bit of this right here and sand down the base plate, which we made out of this board. So for right now, I think what we're going to do is cut the base plate and cut all the items in this board. I need to get a jigsaw. This is not going to work. It's going to be a jigsaw all day long because that's melting. Different plastic, different temperature difference. This is a weaker plastic than the milk crates, so definitely need to do a jigsaw. Still gumming up. This stuff is so easy to melt that just the vibration of that's causing an issue. I may not be able to use this. We'll keep trying, but like it's already melting back. Well, folks, we have been having issues left and right today, especially with the cameras. The GoPro failed on me a few times, saying that there was some type of repair issue. It was trying to repair something. I don't know what it was trying to repair, but it didn't do a good job and cut down on me. And then my Akaso, which is my backup camera, is my initial camera that I did a lot of my action stuff with. It seized up on me. And I've had multiple saw blades and multiple saws not do what they're supposed to do today, so I guess I am jinxed. But finally got it cut out. Not the best in the world right there. You can see it's kind of boogered up, but we can sand that off, nothing big. Sand this off, sharpen this up to be more like a blade. Straighten this out because that's kind of bulbous curve. I kind of got a little cattywampus there. So we're going to straighten that up and then round that off. This other edge is rounded off and this is straight, so nothing to do there. I decided not to cut this. I like that shape, so I'm just going to kind of make a beveled edge so that it looks more like a rudder or skeg. This part right here is going to take a little bit more work, but that sander will do a good job. I'm going to do a lot of hand sanding here. So now we got to cut out 2-3 other parts and we'll be done. Hopefully we can get this taped before another camera breaks. Using jigsaw now, but it's trying to lose energy, so I may have a battery dead there too. So we're going to see how this works. Just been an interesting day. Plus I cut into my bucket. Didn't want to cut in my bucket, but I cut into my bucket. It happens. So I was able to do a lot of sanding on this base plate. It had some sharp plastic, so I ground it down just a little bit so it was flatter, and it did great with this. But this, because it is such a softer plastic and this only has one speed, which is wide open, it was melting everything down and remelting it back onto the board here. So what I'm going to have to do is get some sandpaper and hand sand this. So just realize different plastics react differently to power tools, and so you may need multiple tools like I did to get this to do what it's supposed to do. So I'm going to just hand sand this. A while back, Ricky made me this variable speed knife sharpener, and that's one of my better playing videos. If you hadn't seen that, you might want to see it. But I'm thinking, because it's variable speed, And by variable speed, I mean that it has this little turn knob thing that allows you to change how fast it goes by the amount of electricity it's taking in. I'm thinking I can get it low enough that I can just grind this down without there being a problem. You're supposed to have this bolted to a table. I don't have it bolted down to a table, so I am not operating with regular safety protocols in place. I know Ricky is going to be very upset with me about that, but it is what it is. If you do this, definitely bolt it down to a table. I don't have a workbench with power, so we're doing the best we can do here. I'm going to plug this in to an outlet because it won't fit into my outlet the way we got that cable done. And I'm going to set it at the lowest possible speed, and then we're going to go from there. And I'll show you me working with it. That's doing a fair job. It is still melting some of the plastic a little bit, but not that bad. Alright, so this right here is a butane torch. We're going to see if this will work. You don't need a lot. Just needing to heat it up just a little bit, not much. Not much. Those scratches are going right away. Just melting away. Don't want to put too much pressure on the edge, but just get enough that I got some of those scratches to go. Oh yeah. This is looking good. Probably not recommended by the manufacturer. Also do this in a well ventilated location. After all, you're dealing with plastic and there's God knows what type of fumes. Also, you can get a crank right there, so don't do that. That's getting soft. Gotta be careful. Not the ideal, but it'll work. Good way to straighten it though. That's straightened. What? again, saying this isn't the best way of doing it, but it is a way. It's looking fairly good. This Warrior right here, the battery's been charging for hours and hours and hours as I was working on that Skeg, and it's still not showing that it's fully charged, but we're going to use it best we can. So I'm going to go ahead and get started. I won't bore you with it, but we got to cut these other two pieces here, so that's what I'm going to do. I'm having to do some cutting with this little saw here. It's not the best in the world by a long shot, but it'll do. I've just got to cut about 1/4 inch off, and then we'll sand it and be good. Y'all, just this little hand saw right here, the cutting action of it is so bad that the heat is causing this board to melt, making it impossible to cut almost. We're going to keep at it, but I just wanted to show you that. I'm going to try to do a lot of work right here with the file, and especially get it right in here in this area here, because that's where I need to focus a lot of my work on right here. So I'm going to continue on with this. May switch over to sandpaper, or may switch over to that grinder, but once I get it all worked out, basically using whatever tool I can at the time that's doing the best. This file isn't doing good, I may end up taking the grinder to it. That worked the best, and then torch it, and I'll show you the end result. Alright, this is a 4/40 pan head stainless steel screw. It's teeny tiny, and I've got a bunch of different ones. This is a 3/4 inch. The hex head on these are teeny tiny as well. I'm going to go ahead and put some of these in here so that I can fix the fascia on the sides to the arms, the armature, and that will make it a little easier to compose this product later as I need to. Okay, I used my clamps, and I figured out a 1/2 inch from the end of this, because it's kind of straight, about straightish, and so roughly a 1/2 inch from that is what I'm going to do. Now I'm going to drill some pilot holes in here to hold the fascia to this piece right here, the side part, and that'll add some structural integrity, but it'll also help me later on when I'm fixing some other stuff. One of the other things I noticed is up here, this nut fits almost perfectly in it. Almost acts like a locking mechanism for the nut, which will make it a lot easier for me to screw this in. Just something to think about. Okay, so what I've done is I've already went ahead, screwed the 2 screws in here, one in this one arm that's held together by the super glue, and the other part right here. So that's holding these 2 parts together. Then I've got 2 that's going to go into the base plate on each side, pre-drilled, so that I can just stick it to the base plate and zip them in, and that will act as the functional connection points here. I'll then get a bigger drill bit, and I'll actually drill a hole once I get my pin mechanism set up, and that will fix all that in place as well. Alright, so here it is. Got 2 of those little screws I was telling you about that's connected to this little bracket here, this piece from the egg or the milk crate, 2 right there, and that's all going to the base as well, these 2 at the bottom. So you got, they're going through here to those 2, that milk crate arm, the milk crate base, milk crate arm, cutting board base, or cutting board side, 2 on each side. Alright? Not explaining it too well, but I'm hoping you can get it. Got one up here and one up here. That is that little arm thing, that little C-shaped piece of the milk crate. And then I got one down here in the front that's holding that other piece, that other bracket piece. Then I've got 2 of those 1/4 inch screws holding down the cutting board base here. Now what I'll do is I'll measure in a little while and drill holes in the bottom, and then I'll put my well locks and I'll drill holes in my kayak and put the well locks and fasten it down. All I'll need then is to drill holes through here, and then also do my my pin, and that will kind of straighten things up a little bit right there, and that pin will keep everything kind of going straight. Right now it's a little flexible, not much, and then I'll run my lines. So we got a lot done. It's taken a while. It's been kind of finicky. These little screws right here, they got little nuts and they're hard to get, you know, tightened on, but I was able to do it. Not bad, shaping up very quickly. I love it when a plan comes together. Okay, so this is roughly just about 3 inches across the side. I miscalculated the distance, so the pin I have won't work. One of the things I was going to do is drill a hole in here, and I didn't. I wish I had, but I didn't. So I may end up taking a screw and doing a screw as a bracing here somewhere. I don't know, maybe. It's pretty sturdy, but not as sturdy as I would like, but a lot of this will straighten out over time. So right now I think what I'm going to do is drill a hole here and here, and then that'll let us get the bolt. I'll get a bolt, cross pin bolt tomorrow, and we can use that for the skeg, because it's getting towards the end of the day and we need to be kind of putting up and getting ready. But I do think I do need maybe another nut or something going through here that I can tighten up and kind of keep everything straight a little bit better. I think it would form some more rigidity if I had 2 bolts going across here. May not do anything, who knows. I mean, when you got $23 just in the stainless steel screws and stuff, and then you got, you know, another $12 in the cutting board material, you know, what's another few dollars more? The good thing about it is, to drill the hole, all I had to do is undo some screws, and just I'll put them back in once I get everything drilled out. I'm just doing a pilot hole, that's all. Okay, so got pilot holes drilled here for the pin. I may end up drilling another hole somewhere around here for the screw bolt or bolt just come through, just to kind of hold it in place. I'm still not sure about that, but because there's still a lot of wiggle this way a little bit, I don't like it. I did drill 4 holes here. That's where my well nuts are going to be. My well nuts, they're a lot bigger, so when you drill a well nut, you're drilling a big hole in the kayak. That's the reason why I don't like them. I think that you get a little bit better grip. I kind of contemplating just going ahead and getting some stainless steel screws and just screwing it in, and then I wouldn't have to worry about the well nuts. Then that way if I ever took it out, it'd be easier to repair. And that's what I'm looking at. Am I ever going, in the future, am I going to take this off and put a trolling motor? And right now, the way things are looking, I'm thinking no, but you never know. So what I might do is I'm thinking it's getting late. I'm just going to spray this with a little black paint and try to make it look a little bit more finished. And then tomorrow I'm going to look at this with new eyes. I think that's going to be the best thing to do. Okay, so we have got probably the coldest day in April we've had in years. We're near record low temperatures for April. We're at the end of April right now. But anyway, I've noticed some problems. First off, when I drilled this, I did not move this far enough over here. I should have just came straight up and came around and brought this all the way to the end. So I messed up there with this arc. It should have been straight up and then rounded, and then that way that inside could have been pushed, and then I cut that even. I didn't do that. Alright, so that's one design flaw. The other thing is that I need to now cut back, and that means that that nut that I put there is, or that screw that I put there is not going to work. These two holes actually will not work either. So what I'm probably going to do is move this one here and probably move another one there, and then that will allow me to cut out an area here for the skeg to fall in. And then I'm gonna have, instead of doing well locks or well nuts, what I'm gonna do is just use regular screws, because when you measure out the size of a well nut, I'm not gonna have much plastic holding the well nuts in, so I'm gonna have to use a screw. And then what I'll probably do is take another screw and put it right here, and then I'll have a screw there. So I'll have two little screws holding right there, and then one right there holding this base plate to the other plate. You'll see all that in a minute. Alright, now I'm putting this in. I'm going to wallow this out just a little bit bigger than what I think I need, because the glue's going to hold it. Make sure this fits in beautifully, perfect. Now let's do a proof of concept shot, just to make sure that everything is going like it ought to go. This is glued in, it'll be fine. It'll do like it's supposed to do. Right now it's acting up because it's not glued in. I'm just trying to show proof that this will work. So it kind of goes in like that, locks into place. There won't be that much slack in it because of the metal part. There'll still be some, but not much. And I can always come in with some nuts or something other to tighten that up, and if I find that to be a problem. so I can always add spacers and things of that nature to take out slack. Alright, so now I need to go ahead and glue this in here. I think I may actually make those, nah, I'm gonna keep those holes small. Alright. Okay, so what I did is I just kind of took a torch, heated up the little sides there to melt that down, and then I mixed some 2-part epoxy, this fast drying super glue 5-minute epoxy that I got from the dollar store. Well, Dollar Tree, should be called $1.25 Tree. I think they're going up on their prices again. So either way, this right now is pretty much set. It still has to cure overnight, but it's pretty much set in there now. I need to let it set probably for about a good hour or so before I'd actually want to work on it some more, but you can see I'm touching it and it's not sticking to my fingers. I can feel that it's soft, but it's not sticking. So I want to let this set in place. I'm going to put it between 2 pieces, let it set, let it cure, and then from there I'll hang it on my little Skeg thing. So what we're going to do is just lay this on the seat I've got over here. Now I'm going to take this over and I'm going to screw, or take, not screws, but I'm going to take spray paint and spray paint this. But before I do that, I want to spray paint the heads of the screws I'm going to be using too. So I've got some screws that will be going in to fasten this down to the kayak, and I want to make sure I got those spray painted. So all this is going to get a second coat of spray paint. I'll let this dry while the epoxy over there is drying, and then I'll probably put a coat of clear on top of this just to be safe, because this paint wants to rub off too easily.